Welcome to your deep dive. Looks like you're ready to jump into the world of AI for .NET development.
Yeah, there's a lot to unpack.
We've got a ton of articles here, all about adding some serious intelligence to your .NET apps.
Absolutely. It's incredible how quickly things are changing.
I have to admit, when I think of .NET, I usually think about, like rock-solid business apps, not necessarily AI at the cutting edge. What's driving this surge in .NET for AI?
It's a good question, and that's a common misconception. .NET has always been very versatile, but I think what's really exciting is how Microsoft is creating this unified way to interact with all these different AI services
Okay.
through Microsoft.extensions AI.
So you're saying that instead of having to wrangle all these different APIs, .NET developers are going to have like this single streamlined approach.
Exactly. It really simplifies the whole development process. And then, you've got tools like semantic kernel that are designed specifically for orchestrating these complex AI workflows.
Okay, hold on. My brain's trying to catch up here. We've got semantic kernel, we've got SDKs for OpenAI, we've got SDKs for Azure AI services. How do we even begin to choose the right tool?
It can be overwhelming, for sure.
Yeah.
Imagine you're building this large-scale application and it needs to interact with multiple AI services, pull data from different sources, maybe connect your own custom code. That's where semantic kernel really shines. It brings all these different pieces together.
So semantic kernel is for like the big complex projects.
Yes.
What about something simpler, like if I just want to add some basic text summarization to my app?
Yeah, in those cases, you would probably just use the SDK
Okay.
that's designed for that specific task. So if you need to connect to OpenAI, there's an SDK for that. If you want to use pre-built solutions from Azure AI services, there's an SDK for that too.
So it's all about having the right tool for the job.
Exactly. And the good news is that the learning curve isn't as steep as you might think.
Okay.
Many of the articles you sent, they lay out these clear learning paths.
Yeah, I see that.
You could start with something like building a simple chatbot, and then maybe move on to text processing, like summarization or translation.
That sounds like a natural progression. You start with the basics, get comfortable, and then kind of level up your AI skills.
Exactly. And, maybe eventually you even reach a point where you want to train your own custom AI models.
Okay.
And that's where something like ML.NET comes in, which lets you build custom machine learning models right within the .NET ecosystem.
Wow. Okay, so we've got .NET. We've got all these different tools.
Yeah.
But where do these AI brains actually live? These articles mention both OpenAI and Azure AI services. What's the difference?
Right. So OpenAI is known for pushing the boundaries of what's possible with AI. Their models are incredibly powerful and versatile, but sometimes you need a more tailored solution for a specific task, like image analysis or language translation.
And that's where Azure AI services come in.
You got it. They offer a range of pre-built AI models that are ready to use, along with all those robust security and authentication features of Azure.
So if I need that extra security, or if I want something that's kind of more of a managed solution, Azure AI services might be the way to go.
Exactly.
Interesting. Now, there's one more thing that I wanted to touch on before we move on.
Sure.
These articles also mention the rise of small language models, or SLMs.
Right, yes.
These models are compact enough to run locally. So we're talking about running AI models on our own machine.
It is. It opens up a whole new world of possibilities. Think about faster prototyping, offline applications, and even potentially enhanced security by keeping all of your data local.
This is really cool.
Yeah.
So if I'm just getting started with .NET for AI, what's the one key takeaway?
With .NET, AI is no longer a distant dream, right? It's here, it's accessible, and it's ready for you to explore. Don't be intimidated by the complexity. Break it down step by step, and you'll be amazed by what you can achieve.
That's encouraging. What's next on our agenda?
Let's talk about vector databases. We'll unpack what it means to store information as vectors and how it's changing the way we search and interact with data.
That sounds intriguing. Stay tuned. We'll be right back after a quick break.
Good.
All right. Welcome back. So before the break, we were talking about vector databases and this whole idea of storing information as vectors.
Right.
I have to admit, it kind of sounds like something out of a sci-fi movie. What's the deal with these vectors?
Well, it's not sci-fi. It's the future of search.
Okay.
Imagine you're searching for information on, let's say, healthy recipes
Okay.
in a traditional database. You'd probably search for those exact keywords, healthy recipes.
Right.
But what if you could search based on the meaning of healthy eating, even if those exact words aren't there?
Wow. So we're talking about searching based on the concept, not just the words.
Precisely. And that's where vectors come in.
Okay.
They allow us to represent information as points in multidimensional space.
Hmm.
So whether it's text, images, or audio, each point or vector captures the essence of the data's meaning.
Okay, so how do you turn like a recipe or a paragraph of text into a bunch of numbers that represent its meaning?
Through embedding.
Embedding.
It's like translating human language into a language that AI understands.
Okay.
AI models can generate these embeddings, which basically map the semantic relationships between different pieces of information.
So words or concepts that are similar in meaning end up closer together in this vector space.
Exactly. And that's where things get really interesting.
Okay.
We can start performing semantic searches,
Okay.
finding information that's related in meaning, even if the words are different.
It's a lot more nuanced than just matching keywords.
Right.
This connects to that retrieval augmented generation, or array.
It's got it. Array is really a game changer in AI. It allows you to combine the power of large language models with your own custom data.
Okay.
So instead of just relying on the LLM's knowledge, you're giving it this extra boost of personalized information from your vector database, making the responses more accurate and relevant.
That makes sense. So we've got all these tools and concepts,
Mm-hmm.
but what about the actual work of working with these AI models? These articles mentioned prompt engineering. What is that and why is it important?
Prompt engineering is all about how you communicate with AI. It's about crafting the right instructions or prompts to guide the model towards generating what you want.
So it's not just about asking a question. It's about asking it the right way.
Exactly. Let's say you want an AI to write a short story about a cat who goes on an adventure.
Okay.
A poorly crafted prompt might just say, write a story about a cat.
Right.
A well-engineered prompt would provide specific details about the cat's personality, the setting, the type of adventure, really setting the stage.
So you're kind of giving the AI the context it needs to be creative.
Precisely. And a good prompt often includes clear instructions, relevant examples, and even these subtle cues to kind of nudge the AI in the right direction.
Cues, what are those?
Think of them as hints or suggestions.
Mhm.
Like if you want the AI to generate text in a specific tone, you might include a few sentences in the prompt that exemplify that tone.
Ah, I see. So you're giving it an example without explicitly telling it what to do.
Exactly. There's also this really interesting technique called chain of thought prompting,
Okay.
where you guide the AI through a step-by-step reasoning process.
Interesting. So you're basically breaking down the task into smaller steps.
Yeah, exactly, making it easier for the AI to follow and produce a more coherent output.
Got it. Now, going back to those .NET SDKs for OpenAI,
Yes.
the articles mention Azure OpenAI SDK.
Mm-hmm.
Which one should you actually use?
Well, think of it this way. The OpenAI SDK is your all-access pass to OpenAI models, regardless of where they are hosted.
Okay.
The Azure OpenAI SDK is more like your VIP pass to the Azure ecosystem. It's specifically designed for seamless integration with Azure OpenAI resources, leveraging all of Azure's security and scalability features.
So if I'm already all in on Azure, the Azure OpenAI SDK is probably the way to go.
Exactly. It just provides a more managed experience. And it has features like managed identities for authentication.
Managed identities, what are those?
It's a way for Azure to automatically handle authentication when you're accessing OpenAI services. So instead of managing API keys directly, Azure takes care of it behind the scenes.
Gotcha. So it's a much more secure approach.
Exactly. And these articles mentioned other authentication options like role-based access control or RBAC.
What's RBAC all about?
Well, with RBAC, you can make sure that the right people have the right access to your AI resources.
So it's all about being granular with permission.
Exactly. You can define different roles like AI developer or AI user and give each role specific permissions.
That makes sense. Okay, so we've got the SDKs. We touched on security.
Right.
Now let's go back to those vector databases. Azure AI Search, Azure Cosmos DB for MongoDB, sure, Redis. How do you choose the right one?
It depends on what you need, really. Azure AI Search is great for large amounts of text-based data like document search or product catalogs. Azure Cosmos DB for MongoDB is more flexible, it can handle different types of data, and it has built-in support for vector search.
And Redis.
Redis is all about speed. It's perfect if performance is critical, like real-time AI or caching frequently accessed embeddings.
So the choice really depends on my specific application.
Absolutely. There's no one perfect solution.
Okay, so we've got OpenAI, we've got our vector database filled with all these insightful embeddings. How do we actually build something with all this?
That's where semantic kernels plugins come in.
Okay.
You can think of them as modular building blocks that extend the capabilities of your AI application.
So plugins let me connect my AI to other parts of my application.
Exactly. Semantic kernel provides pre-built plugins, but you can also create your own. So you can connect to external APIs, databases, your own custom code.
Very cool. And I also saw these planners mentioned.
Oh yeah, planners.
What are those?
Planners are like the master strategists for your AI. You give them a goal, and they figure out the most efficient way to achieve it using the available AI models, plugins, and resources.
Wow, that's powerful.
Yeah, they can automate those complex decision-making processes.
This is all mind-blowing stuff. We've covered so much already, but I have a feeling there's still more to learn about .NET and AI.
You're right, we're just scratching the surface, and .NET is going to play a huge role in the future of AI.
Well, that's a great place to leave it for now. When we come back, we'll wrap up this deep dive with some real-world applications, responsible AI development, and some final thoughts. Welcome back to our AI for .NET deep dives.
We've covered a lot of ground.
It really has been quite a journey, but I feel like there's still some more wisdom we need to glean from these articles.
Yeah, there are definitely a few more interesting things to explore.
One thing I keep seeing is this idea of agents and co-pilots working with LLMs.
Right?
What exactly are they, and how do they fit into all of this?
Well, you can think of an LLM as this powerful brain with all this knowledge but limited ability to interact with the world.
Okay.
It can process information and generate text,
Right.
but it can't really access external data sources or send emails or, control devices.
So it's like a brilliant mind stuck in a digital box.
That's a good analogy, and that's where agents and copilots come in.
Okay.
They basically act as bridges between the LLM and the real world.
So they give the LLM a way to actually do things in the real world.
Exactly. Agents are more autonomous. They can carry out tasks on behalf of the LLM, like fetching information from a database,
Okay.
sending a message, or even controlling a smart home device.
So agents are all about automation.
Yeah.
What about co-pilots?
Co-pilots are more collaborative. They work alongside humans, providing assistance and insights in real time. Think of a coding co-pilot that helps you write better code
Okay.
by suggesting completions, identifying potential errors, maybe even generating documentation.
It's like having an AI pair programmer with you.
Exactly. They enhance human capabilities.
The articles mention the semantic kernel chat co-pilot.
Yes.
What is that?
It's a reference application that shows you how to build a chat experience with an AI agent using semantic kernel.
Okay.
It really highlights the core concepts of creating these intelligent chatbots that can understand natural language, access information, perform actions, all within .NET.
So it's like a blueprint for building AI chat applications.
Precisely.
Now, let's talk about something really important. Content filtering.
Yes.
These articles explain how OpenAI's filtering features work.
Right.
But how do you actually use them in a .NET application to keep things, safe and appropriate?
The good news is the Azure OpenAI SDK and semantic kernel make it pretty easy.
Okay.
You can configure them to automatically flag or even block outputs that violate your content policies.
So you can build in those safety checks.
Exactly. You can customize the filters to align with your specific needs. Like if you're building a chatbot for kids, you can make the filters extra strict.
That's great, especially as AI becomes more prevalent.
It's really all about responsible AI development.
Right. Speaking of responsible development,
Yeah.
these articles also talk about the ethical side of AI. As .NET developers, how do we navigate these challenges?
It's a really important question. I think, first of all, we need to educate ourselves about the potential pitfalls, like bias in training data,
Okay.
or the unintended consequences of AI decisions.
So it's not just about the code, it's about thinking through the impact.
Exactly.
Right.
We need to consider the ethical implications and try to build AI systems that are fair, transparent, and accountable.
It's a shared responsibility.
Absolutely.
So as we wrap up this deep dive, what's the one key takeaway you want our listeners to remember?
AI is here, and it's accessible, especially with .NET.
Right.
Don't be afraid to explore and experiment. But as you do, remember to approach it with responsibility. Think about the ethical implications, and let's work together to create AI that benefits everyone.
That's a great message. The future of AI is in our hands. Let's make it a good one. Thanks for joining us on this deep dive.
It was my pleasure.